Corporate finance practice problem using Excel. Payback period computing projects of different lengths. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, just note that we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We have the information on the left-hand side, populating that information into the blue area on the right-hand side, working for a payback type of calculation, one of many calculations we might put in place where we have a situation with a long-term financial decision that we're putting money into, an initial investment that we're expecting to receive returns on in the future. And we're going to have two projects, this time comparing projects that have different lengths, one having 3 years and one's going to be 5 years, in which we think the payback period will extend. Now, this is to highlight one of the problems with the payback period. Remember, this is just one of many types of calculations that we might put into play. Our goal is to think about the future when we look at these long-term projects, take different types of calculations that might help us to get some idea, look at from different angles these projects, and then make the best decision. The payback period is the one that we're looking at to see when we're actually going to get our initial investment back, not taking into consideration the time value of money. And then we would probably want to do some other calculations, as we'll do in the future. So we're going to have the investments, going to be the 100,000. The cash flow options, we got project 1 or product 1 and product 2. You could think of a similar situation if it was a product, if it's a project. So if we're buying something, selling it, if we have a project, if we're investing in equipment or something like that, that of course the reason we are investing in it is so that we can get a return on it. Then the question is, well, how long will it take before that return gets us our money back? So obviously the two first things that come into our mind are going to be, well, how much money are we going to get? What's going to be our return on the investment, and how long is it going to take before we get, the revenue related to our investment of, in this case, the 100,000. So you could do a simple calculation on that. We got the 100,000, but these are going to be the years. It's going to be a 5-year project for X, and for Y only 3 years. And the payments that we expect to be receiving after the initial investment, 30,000, 20,000, 25,000, 50,000, 40,000 for the X project or product, and 35, 30, and 35 for Y. Now we could just calculate the net gross revenue we expect to receive, which would be equal to the 100,000 minus, if we take project X, the sum of these items, shift 0, and I'm going to say that's 65,000 versus we're going to take the 100,000 minus the sum of project Y, and that's going to be, let's do that one more time. This will be actually, this adds up to 100,000. We'd actually break even. So just on the face of it, you're thinking, well, project Y doesn't look good really, because we're basically breaking even there. And this is kind of to highlight that if you just looked at the payback period, then you could end up with a result that doesn't make sense if you don't take into consideration, other factors. So let's break down the payback period. Let's do project X first, or product X. We're going to say the initial investment. We're going to just do our running balance type of calculation, and then we got to figure out the fraction of a year, often the more complex component. So investment is going to be equal to the 100,000. And then we're going to be saying from years 1, 2, I'm going to use the autofill, selecting these two cells to fill handle, grabbing the fill handle, in other words, and dragging it on down so we get the 5. And then we're going to be picking up the alignment and center the alignment. And then I'm just going to pick up the payments, which I could just copy and paste, but I would rather use the autofill by saying equals, picking up the 30,000. So we're taking our information from our data point. That's always good practice to do when we're working with Excel, grabbing the Excel handle, dragging it on down. Again, there is our payment stream. So all we're going to do is have a running balance until the 100,000 flips from positive to negative, which will mean that we have gone from covering our investment to actually getting a return above and beyond the investment. So this will be equal to the 100,000 minus the 30,000. After year 1, we still have 70,000 that we need to cover. So this is going to be equal to 70,000 minus what we expect to get in year 2, 20,000, leaving us with 50,000 of the original 100,000 that we still have not recovered. Year 3, we got the 50,000 minus the 25,000. That gets us to the 25,000 that we still have not yet recovered. And then we're going to take the 25,000 minus what we expect to receive in year 4. And there we go. We are now past the point. We've gotten our 100,000 back at that time. Note that you could do this with a running balance calculation. If there were many years, I'm going to delete these cells and just do it one more time. So we're going to say that this is going to be equal to the 100 minus the 30,000 year 1. Going to put my cursor on that cell, take the fill handle and drag it on down, and then all those cells will do what they relatively should do, and it breaks it out for us very nicely. So most of the time people are pretty good at this, meaning they see it's going to flip from the 25 to the 25, and we've basically recovered our investment at some point in year 3. And then it's that fraction of the year that can be a little bit tricky. Also note, remember, they can represent that fraction of a year in different ways. They can say this many days, this many months with a fraction on it possibly, or just a fraction of a year. So you want to be able to just compute that last component, especially if you're under pressure on a test question for it. So to do that last piece, you could say the amount still needed. This is kind of the quickest way to do it. We'd say from this point in time, we still need 25,000. 25,000 is still needed. And the amount from the next year that we're going to expect to earn, and we're expecting we earn it evenly over the year, is going to be that 50,000. So the partial year calculation then, the fraction of a year is going to be equal to the 25,000 over the 50,000, or in this case, if we add the decimals number group, adding a couple decimals, 0.5. So I'm going to put the underline under the 50,000, and this is going to be the payback. So the total payback is going to say it's going to be after year 3, so it takes 3 years, plus that fraction of a year, 0.5. Now, obviously, that fraction of the year you can represent multiple different ways. You can say, well, if they want it in months, you could say 12 times the 0.5, adding a couple decimals, about 6 months. You could say they might want it in terms of days, right? You could say the 360 about days in a year. If you had 12 times 30 even months times the 0.5, we get about 180, Or we can do a running balance. Sometimes it just makes sense to do this running balance again. I think it's just good practice to do this running balance. So let's do this for the whole year and see what this would look like. 1, 2, I'm just going to select those 2 cells. I'm going to bring it all the way down 365 days. All the way down. And you can do this by month too, by the way, which probably would have been a more practical thing to do than this whole way down. But we have Excel, so we can do this, and it's not even a problem. So there's that. And then we're going to say the fraction of a year would be then 1 day over 360. And then I can copy that all the way down, grabbing Phil's handle, copying it all the way down again. And so there we have that. And then we can say that the amount that is going to be applied out for this period is going to be the 50,000. We're picking up the 50,000 here and then dividing it by the 360. So we'll divide it over the 360 days. And there we have it. So we're going to imagine it's even over the 360 days. So I'm going to copy this all the way down using the autofill. Auto drives it down. Dr. Phil does the calculation. Autofill. Scrolling back up. I'm also going to select column J here and add some decimals, numbers group, decimals. So we can see stuff going on there. A little bit more interesting that way. And then we'll have our running balance calculation. Really good to get good at this running balance calculation. It's good to get good at being good. So that we got the 139 plus the 139. And then we'll copy that down. So we'll go to the autofill once again, running balance calculation. Once we get to the bottom, it should get us back to that 50,000. So driving it down, fill, auto, fill. There's the 50,000. So there we have it. Now we're looking for that 25,000 now over here. So where do we hit that 25,000? Should be about halfway down. Looking for the 25,000, 25,000. Is there a 25,000 round here? And there we have it. So the 180 exactly halfway down, just as we assumed. It's just another way to see it. There's that 180. There's the 0.5 fraction of a year, 180 days. So you can go back up top. There's the 0.5. So there we have that. All right, so let's do the other one now. I'm going to go ahead and hide some cells from E. I'm going to go from E to M. We're going to hide from Right click on the selected area and hide. So now let's do the same thing for Y, which only has the 3 years that are covered. Now we're only looking 3 years, so we'll have the initial investment. So I'm going to say this is going to be the investment, which would be the same for the 100,000, and then years 1, 2, and 3, and center these ones, and then we'll have our running balance, which are just going to be equal to the 35,000, and then I'll use my autofill to fill it on down, like so, and then we're going to do our running balance calculation, subtracting out this time. The 100 minus the 35 means we need to cover 65,000 after year 1 still has not been recovered. 65,000 minus the 30,000 is going to be 35,000 left. And then finally, we have the 35,000 minus the 35,000. We covered our investment. It only happened in 3 years. Great. Except we didn't make any money from it, right? So that's where kind of the drawback is with this calculation, because obviously it's just calculation when we cover the investment, and we want to make a profit here. So when we stop right there, it's not taken into consideration at kind of a crucial point, which is, are we making money after that? And that's why we need other calculations in conjunction with the payback period. That's going to be a primary kind of theme you'll see within test questions, is the limitations of something like a payback period, although it's still useful. So then we're going to go down and say, okay, well, the fraction of the year is obviously not really applicable here, because like it's the whole year. So it would be like basically 1, because we don't have any fraction of a year. So then the payback period would simply be the 3 in this case. And then we could do the partial year comparison, but it doesn't really matter because, again, it's 1, so it's an even breakout. So we don't really have a partial year, so I won't do it this time. Because the main point here, the different thing we're looking at is this thing. So now we're going to analyze the what happened. Let's unhide now. Let's go from column C. I'm going to put my cursor on C and N. Sun, CN, CN, right click. I'm seeing it. And then we're going to unhide so we can see in it. Now we're seeing it. All right. So the first one was 3.5. So that it's going to take us 3.5 to get paid back on the first project. And then on the second project, it would only take us 3 years to get paid back. So using the payback period, which project would you choose? And you choose project B, or the second one, whatever we called it. B, Y, Y. But why would you choose Y? Because Y doesn't make any profit, right? Y, had 0 profit at the end. But under the payback period, we'd still choose it if that was the only thing that we used, because it's getting paid back sooner. Often the case where you have a problem if you're comparing 2 different projects that have different lengths. So if you're comparing 2 projects that are kind of the same in length, and have, the payback period might come up with an answer that's relevant even without time value of money, given the fact that if you get paid back sooner, it's usually better. But if you have different time lengths, then the payback period when you compare 2 different projects probably is certainly not the only comparison that you would want to use, although, again, it might still be applicable. So that's the typical thing you're going to see in test questions. They're going to say, which would you use with the payback period? And we're going to say, well, we would have used the Y one. And then, does that make any sense? And we're going to say, no, that's silly, because we don't even make a profit for Y. And after the time value of money, we actually would have lost money on it. So what do we need to do as the solution? We need to take into consideration calculations that include the time value of money and go beyond simply paying back, but also what's the benefit of the profit that we're going to make above and beyond. That doesn't mean the payback period is not useful. It just means, of course, it has limitations. When you're trying to do these comparisons, it's just one tool to have, not the most powerful tool to have. Probably present value calculations being, the most one that we want to rely most on when we get down to the final decisions. But this might be a good one for like our initial kind of decision, our initial kind of comparison, quick calculation type of problem.